mouse spiking.
So inform in your WhatsApp group to join, because today's class is really very important. That cannot be repeated also, and problems are there. So it is better everyone joins the class.
Ma'am, yesterday's PPT still we didn't receive any, ma'am.
Yeah, I didn't send it. I'm just reframing it so that it will be easy for you to understand. Today night I have almost completed it. Today I will send it. And I found out your exams will be in the month of end of February or March. And university will be calling you for practical. 6 days they will be calling, it seems, in the month of January.
Yeah,
okay. Yeah.
No, records will be right, ma'am.
Records that after your practicals, you have to start record work.
Okay, okay.
Yeah. Because the content of the practicals will be a little different from this thing. That time only they'll give you the assignments to work out. But I feel whatever the university gives the assignments, that is well and good. In the meantime, you at least write the answers of what I'm sending it, and try to send it to me on WhatsApp. That will be definitely make you prepare for the exams. What I send.
Ma'am, may I know your number, ma'am? We don't have.
My number will be there here on the WhatsApp, on the chat box should be there, or you can send the message.
Ma'am, once again send my message.
Send me a message, ma'am.
All of you will be sending. I have in my college accounts also. That's why I didn't send my number or other things.
Because, ma'am, we don't have any materials or any model papers.
Yeah, no, that's what I will be sending you, dear. Once again, let me stop it.
Books not be there, not there, ma'am.
Why we are viewing Maha's screen? Who is Maha? Who is Maha? I didn't make you the host, right? Yeah. So class is today only. I will be teaching. Yeah, I'll send it, Ma. I'll be joining the WhatsApp group. There I will be sending you. Even if you send me personally, it will be difficult for me. My own college students are almost 500. So those messages, those groups and all are there. I'm joining that WhatsApp group today. So I'll be sending all the information through WhatsApp. Yeah. Any information you want through WhatsApp, you can contact.
Thank you, ma'am.
WhatsApp link is already there. Yesterday, sir sent to me, and it should be there with you people also. I think all of you have joined that WhatsApp group, right? In that, I will be sending all the information.
Okay, ma'am. Thank you.
Okay, done. Yeah, just give me one day. I'm working on it. And today, let me start the class completely today about the binary. All of you have learned about binary, octa and all. The memory, what we have learned yesterday, based on the memory, in what format the memory is stored. That's what we need to work on. Okay. So I will mute you till the class gets over, and at the end you can keep. Again, whoever has joined now, I'm telling you, keep a paper and pen along with you so that you can understand the concepts. If you are only listening, then you won't be able to follow. Okay, and any problem, you raise your hands, that will be visible for me, and I can stop and then explain you once again. You can tell once again, ma'am, so that I can repeat the concept. Is it okay? So today only one unit. I'm not doing 2 units like all the days. Pardon?
Excuse me, ma'am. Are you hearable? Hello?
Please mute yourself, all of you. The mute part is not.
Hello, excuse me. Are you hearable, madam?
Yeah, I can hear you. Please say.
Madam, there are a lot of groups, madam. Madam, may I know which group you are sending the PPT and PDF?
I will just let me check on that. I'll send that link what I got it.
Inform madam, in Imran's group you will share the PPT.
What Imran shared yesterday in the chat group, right? I have that. I'll say, are you all there in that group?
Yes, madam.
Then I'll share then that. What group I have, I'm sending you. One sir sent me from university.
Okay,
I'll show you that group. I don't know whether it is Imran's group or what group it is. Copy link address. Yes. Zoom meeting. I'm putting in the chat box. I'm sending here. This is the link what I received. So are you there on this group or the other group? I think this is the one I have seen yesterday through Imran also.
No, madam.
Imran, are you there? Imran, are you there? You decide to one group, children, so that I can send in one group. If you are into different groups, then it will not be easy for me to send the information. Okay.
Ma'am, now you are sending this group.
Yeah, I will send into this group because I will be joining from university. I got this link. So I'll be joining that group. I'll be sending
members are joining in this group. I also join. Please send in this group, madam.
Yes, all of you join this group. I'll send the information in this group.
Okay, madam.
Okay, ma'am. Thank you.
Okay. Yeah. So that group will be there in the chat box. You can always see. Done?
Okay, madam. Thank you.
Now I need to mute you all. There is mute option not there. Mute option is not coming. Why? Okay. I'm not able to see the mute option here today. Yeah. So now, let's start the class today. I hope all of you are able to hear me. Can you show your thumb? Can you hear me? Can you all hear me? Okay, done. So let me show you the 7th unit. Just a second. Stop sharing. Unit 7. Now, so 7th unit is about the number systems. Number systems means we have the decimal system. The numbers 0, 1, 2, 3, 4 up to 9 numerals we call 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 are called numerals. And the 10th number is nothing but 1 and 0 again. Then 1, 1, 1, 2, 1, 3, 1, 4. So in the decimal form, if you see 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. The 10th number what comes is 1, 1 and 0. 11th number is 1, 1. 12th number is 1, 2, 1, 3, 1, 4 like that. So here, how does the numbers is the normal numbers what we are using in the daily life. But how does the system understand, the computer system understand, so that it will interpret your information into the digital format and then process the information. So here we have the objectives of this is the introduction. What are the logic gates we have? Binary number system, octal number system, hexadecimal number system, and the summary. So the objectives is to understand the logic gates. Maybe if you have done your 10th class, you might have learned about this kind of things. In the sets and sequences, you have learned about the statements and sets. There are statements. if it is true, true, then what it is, true, false, what it is, etc. That kind of number systems you might have learned. So here also we are doing that logic gates recall. So in the various types of logic gates are there. Then comes to the number system, binary number system, then octal number system and hexadecimal number system. So here the CPU, the important things that are there in the CPU is the arithmetic and logical unit. This arithmetical and logical unit needs to transform your information into the logical formats and then send it to the storage units. So both the ALU and both the CPU and the storage units should know the information and then should store it in the different format, in not the same format what we are speaking. It changes into the different format, put it in the, usually in the beginning days, it was binary, then went to octal, then went to, now it is hexadecimal. Hexadecimal means 16 digits number. Every number, whatever we are writing, is converted into 16-digit format and then it is stored, not into 0 to 10 format. Okay. So there is a Boolean algebra what we have. In the Boolean logic involving logic gates and flip-flop logic we call. We have logic gates. Logic gates are nothing but they look like this. I'll show you the logic gates. The logic gate consists of one or more electronically connected switches that implement Boolean logic process. The process consists of logic operation, one on or more logic inputs. Either you can call it as 0 or 1. That generates a solitary logic unit output. So you are putting, suppose two things are there, two informations you are giving. One is 0, another is 1. So these two together, 1 or 0 or 1 and 1, 1 not 0, something like that. Different logical statements we can make it so that it understands in that manner and then converts the data in that format and then work on it. So I'll show you first one, the AND gate. This is called the AND gate. In the AND gate, we call, this is AND. AND means both together. Both together means both A and B. Two switches are there, both A and B should work. So A and B, A and B together means what is the output that is going to come? If A is 0, B is 0, then AND gate will give you the output as 0. If A is 0, B is 1, but 1 and 0 together, it will become 0 only at the end. Are you clear? Then 0, 1 and 0, 0 and 1 or 1 and 0, both and no. And means either this and this. So both when we are talking, it will convert it as 0 only. But wherever both are 1 and 1, both are yes, yes, both are true, true, both are false, false. In that case, it will give you the output as 1. So AND gate we call input and AND gate. In that, if both A and B, how they are. If both are 0, it will give you 0. Either of them is 0, it will give you 0. But either of them are 1, both are 1, then it will give you only 1. Then we have next one, OR gate. OR means ye bhi ho sakta, wo bhi ho sakta. Any one you can take. So either 0 or 1, both 0 means 0 hi lega, but 0 or 1. So any one you can take, right? So it will take 1. Then 1 or 0, then also it will take 1. And 1, 1, it will take 1. Because there is no 0 here, it will take 1. So here remember, when we are taking OR gate, the OR gate is an electronic circuit that gives you high output of 1. Most of them are 1. In the previous case, if you see, the most of the outputs are zeros. 3 zeros we have, whereas now we have 3 ones. Three ones we have in the OR gate, and in the AND gate we have only 1 and 3 zeros. So AND gate it is 3 zeros. OR gate if we find it is 0 0 means 0 and either 0 or 1 means kaunsa bhi aapke paas, if you have this or this, anyone you give me. So 1 it will take, anyone. So answer is 1. Then comes we have the next one, NOT gate. NOT gate means this is not. So if A is 1, like a complement, in the set we call it as a complement. What is there that we don't want, other than that we want. So it is like a complement. If A is 0, A complement will be 1. If A is 1, A complement will be 0. So this is called NOR gate, or you can call it as NOT gate. So NOT gate is a circuit in inverted version of the input. Whatever input you give, it will take the negative of it. For example, if you are having delete option, so whatever information you are giving, it is going to delete that option, delete option type. Then we have XOR or XOR or EXOR. Exclusive OR. XOR is nothing but exclusive OR. Gate is a circuit which will give a high output of 1. Of course, many will be 1. Even the number of ones is high, or the high voltages as input. The encircled plus sign, circle with plus sign, is used to show the XOR, EXOR function. So if A and B are there, there is a XOR function in that. Here it is taking exclusive OR. So A, B, both are 0, it will take 0. A is 0, B is 1, it will take 1. A is 1, B is 0. It will take the first one what is there, and then according to that, it will convert the answer and then give you the final answer. So this is a little complicated to make it understand. So A 0 means both are 0 means 0. Both are 1s means it is 0. In the previous case, you have both 1 means the answer is 1. If you can see here, both are 1 means the answer is 1. Both are 0 means the answer is 0. This is input OR gate. Whereas XOR gate, it is exactly the opposite. I'll bring the XOR gate here, which you can see. Let me copy this once and bring it near this gate, so that you can see the difference between both of them. Now you see the XOR gate. This is input XOR gate, and this is simply OR gate. XOR gate means it is exclusive OR. Both are 0, 0 only. 0, 1 is 1, 1, 0 is 1. This is also same. But when you are giving both false or both true, it will give you the answer as 0. That is the difference between exclusive OR. Okay. Then comes, this is NOT AND. XOR gate is done. Okay. NOT AND we call. NOT AND means what? This is, if it is given as both as zeros, it will give you NOT AND. Not both are 0. No, I will take only 1. So AB complement we can call. So both 0 means it will give 1. Any one 0 also it will give you 1. Any one 1 means it will give you 1. Both ones means it will give you 0. That is called NOT AND. Not exclusive OR and NOT AND are little opposite to the original AND and original OR. Okay. Then comes, we have NOR gate. This is NOR gate means A plus B whole complement. So here we have both 0 means it is 1. Both 0, 0 only, but complement if you give A plus B whole complement is that opposite is 1. Then 0 and 1, the opposite actually it should be giving you 1, but the answer will become 0, opposite of 0. Then both 1 means it has to give me 1. 1 and 0 means it has to give me 1, whereas it will give you the answer exactly opposite to that, that is 0. Then 1, 1 means it is nothing but actually it has to become 1, but it will give you as 0. Remember here, AND means it is like intersection in the sets part, and plus means it is OR in the union type. In union we can call it 0 union 0 means it will be 1, and 1 0 union 1 is 0, like that. You have to remember the values. Then we have XOR and EXNOR, XNOR and EXNOR. Exclusive NOR we can call. A plus B whole complement it is. A circle B whole complement it is. These are the values what we are going to get. Here the circuits, if you have to, how you have to learn is put the values next side by side, then it will be easy clearly and you can understand them, the concepts. 1 second, I'll put them here. Can you see the values now? 0, 0 is 1, 0, 1 is 0, 1, 0 is 0, and 1, 1 is 0 here in XNOR. In XNOR it is 1, and NOR it is 0. Slight difference only, of all the values are almost the same manner. Then multi-input logic gates. Multi-input logic gates means you are giving A and then something in B, something in C, and all should go on. We don't do all at once, right? We don't go slowly one after the other, all giving the inputs. We give the inputs, first input A, then second input, then third input. Like that, we keep giving the inputs. So when we are giving the inputs in different manner, the truth table, you have learned the truth tables in 10th class, I think, right? Do you remember the truth tables? Statements and sets in that truth tables are there. True, true, false, false, true, false, false, and false is false. Something like that. So this kind of equations you should remember. I will write and then send you if you don't remember them. Then truth tables are drawn using the output of the current step as input to the next step and so on. So first of all, it will check AND or not. What is it the AND gate or is the OR gate? So AND gate looks like this, OR gate looks like this. So which gate it is? And then it will check both. Then go for the next one. Like that, it will go on. Then we have the following represent. See, A or B, first one I told you, OR and AND. So 2 gates OR and 2 gates AND. So it will go to XNOR and then from XNOR, it will give you the answer. So AB is at one place, CD at one place, then 0, 0, 1, 0, all those values we have to put and then calculate the values. Then we have binary number system. From here, actually, the concepts will become little complicated for you. So binary number system means whatever be the numerals. Let us talk about the numeral concepts. All the numerals we have 0 to 9, we have the numerals 1, 2, 3, 4, 5, 6, 7, 8, up to 9 numerals are there, right? 6, I can put it as 1 second. I'll extend this. 6, 7, 8, and 9. So these are the numerals what we have. But after 9, you are getting again what? 1 and 0. Then 11 means 1, 1. 12 means 1, 2. So this is not 11 when you are talking about 10. It is 10 and 0. That's it. 10 means it is 10 and 0, not 10 plus 0. Right? So, suppose if I put 11 does not mean it is 1, 0 plus 1. Are you getting my point? 11 means 10 numbers are done, plus 1. 12 means 10 plus 2. So remember this, up to 9 numbers it will become, and next number again 20 it will become. Clear, all of you? So that is how the numerals of the decimal system, what we use on a daily basis, we are working. But the computer system does not understand this kind of decimal systems. It understands the binary values or octal values or hexadecimal values. So let's see how to work out with the decimal number system. When you see, whoever is drawing this, please stop it. So a conversion of binary to decimal. In the decimal part, if you see your first number, I will put in the binary number system that part. Just let me stop sharing this. I'll go to the number system only. I hope all of you are having a paper and pen so that you can understand it easily. Carefully see. Now, I'll put one more table so that it will be easy for you to understand. Can you see the screen, all of you? Mayuri, can you see the screen? Abdul, are you able to see the screen? Hello? Kanta? Okay, done. So now here I'll put this number as 10. Just a second. So this starts with our first number is 0. How did you get this number as 0? You got that is nothing but 10 to the power of 0. If you remember this first number what you got, it is nothing but 10 to the power of 0. Here this part you see. Don't see the numbers down there. I'll show you the number system and then 10 number system if you learn, it will be easy. 10 to the power of 0 is nothing but 1. All of you know this, right? 10 to the power of 0 is this thing. So 10 to the power of 1 is nothing but 10. So you will have 10-digit numbers. I mean, the units place is 1. Tens place is 10. 10, 20, 30, 40, 50, up to 90. When it completes that part, it will go to the 10 to the power of 10 place, that is 10 to the power of 2. I'll copy this 1 minute. This part is up to 5 numbers I'll take. The remaining will leave it. Time being, I'll take only till 5 numbers. 10 to the power of 4. Okay. You can say, what is this values? First number, this is tens place. This is, units place. This is tens place. When you take 10 square, it is 100. Hundreds place we have. You remember that hundreds place? Then we have, this is thousands place. And this is 10,000 place. Right? And this is 1 lakh. 5 to the power of 5 means it is 1 lakh. So units place, tens place, hundreds place, thousand place, 10,000 place, like that. Each is a place, right? So this is how we have our numbers. Suppose if I have a number 2, 3, 6, 7, 8, 4. So how do you read this number? 2,35,794. This is how you read. How do you read this number, all of you? 2 lakhs, correct? 2 lakhs, 35,794. This is how you read your decimal numbers. Same manner, we are going to work out in the same manner for binary numbers. What are the binary numbers? They are nothing but 0 and 1. Binary numbers, we don't have anything. They are simply 0 and 1. Okay. So wherever the numbers are there, it will take only 2 numbers, that is 0 and 1. Nothing else more than that. 0 and 1 only will be taken all the time. No matter how big number, 355, 894, 1255, any number you take, that will be converted into binary value. So how do we convert them into the binary value? I'll show you one small simple example to make it into the binary value. Suppose I will take a number of 135. Let us take one small number, 135. I'll take a little more bigger size in number. So 135, I'm taking some small number of some number I got, it got this thing for me. So what I'm going to work for this number is I'm going to put it in the table format. Actually, you remember LCM method we call. So in the LCM method format, I'll be doing. Okay. So carefully observe how I'm working out to get. This is in that 135 is in what format? It is in the decimal format. I'm converting it into the binary format. Binary format means you will have only 0 and 1 as the numbers. So my number is 135. What I do is I will divide it by 2. When I divide it by 2, how much number I'm going to get as the answer? 2 6 are 12. I'll get one reminder. 15 is there. 2 7s are 14. Then I will get 1 as the reminder. Correct? So I'm dividing LCM method format, you remember? So when you divide 135 by 2, you are getting 7 and remainder is 1. I'm writing the quotient here. I'm writing the remainder here. Then again, I'm dividing it by 2. What number I'm getting? 2 3s are 6. And again, 3 is there. So 2 3s are 6. Remainder is 1 remainder. I can write the 1 remainder as answer. Then I will divide again it by 2. Then 2 16s are 32. I will have one more remainder. Again, I will divide it by 2. Sorry. Again, every time you are dividing it by 2, you got 8, but there is no remainder. The answer is 0 for me. Again, I will divide it by 2. The answer is 4. I get the remainder as 0. Again, I will divide it by 2. The answer is 2. Again, my remainder is 0. Again, I will divide it by 2. The answer is 1. The answer is 1 and the remainder is 0. Now, these are the numbers I got from the table. So, I hope all of you have understood. Any questions till now? Binary system? I'll unmute you all so that you can say. Any doubts?
No, ma'am.
No, ma'am. No, ma'am.
No, ma'am.
Okay.
No, ma'am.
So now when we are working like this, how do I write the number? This is division, ma'am. You got the division values. So how do you write the numbers in the division format? So just a second, I will put it in the LCM format for you so that you can understand it easily. Just a second. It is a con. Just a second. I'm going to work out on that. Yeah. So let me clear all this first of all. The values. Because in the system, if I have to show you, I have to show it in a better way, right? Now this is your LCM method, what you get to work on. This is how it looks. Now is it clear? The LCM method, 2, you put like this numbers and all, you will get the answers like this. Now how do I write this as the binary format? If you see carefully, the number start from the bottom, 1. Let me take the value. Writing on the system is a little tough. So 1, I'm starting from the bottom, this number 1, then comes your 0, then comes one more 0. How many zeros are there? 1, 2, 3, 4 zeros are there. 3, 4 zeros, then 3 ones. This is my 135 number to base 2. This is my 131 to base 2. For what number you got 131 to base 2? That is 135 number to base 10. That became 135 to base 2. Is that clear for all? Is equal to. Is it clear how it is done? So I can convert the decimal format into the binary format and the system will understand the binary format. Whatever number you are putting, just 9 or 8 or 7, it will convert everything into the binary format and then store it in the data set. So if I have to convert back this number, if I give you one number, can you work out quickly and then tell me the answer for that? I will give you the number as okay, 197. Can you work out all of you quickly? 2 minutes time I'll give. 197. I want it in the binary format. 197 in the binary format. Put your number in the chat box. I too will work along with you. 197 divided by 2. 2 9s are 18 and 17 is there. 2 8s are 16. 1 balance and 2 once again. 49. Answer is 0. Then 2 again. Then you have 24. Again, balance 1, 2, 12, 0, then 2, 6, 0, then 2, 3, 0, then 2, 1, 1, then 2. So I got 1, 1, 0, 0, 0, 1, 1, 2, 3, 1, 0, 1. Yeah, how much number did you get? Perfect. No. 1, 1, 0, 0, 1, 0, 1. Perfect. Whose is this? Imran. Very nice, Imran. Perfect. So that's how we get our number. So when we work out the number, shall I show you once in the system that part? I'll draw once again that this number. So I'll take the table once again for you people. Table. Let me take, because in the system, if I have to do all these methods. Otherwise, directly it will come. That's where I told that today class will become a little lengthy. Because all the problems we have to do on the system. That's why. And let me put the decimal value 0. Yeah. So what is the number I gave? 197 I gave. Now I have to divide it by 2. So when I divide it by 2, how much are you getting here? 98. Because 2 9s are 18, 1 is left and 17 is there. 2 8s are 16, remainder is 1. Again, I am dividing it by 2. So you are getting it as 49. Because half of that is 49. So answer is 0 for you. Sorry, 0. Then again, if you are dividing it, 49 means half of that is 24. The remainder is 0. So you are getting you are dividing it by again 24. 12. The remainder is 0. Then divide it by 2 again. You got 6. Again, remainder is 0. Put the remainder all the time. Then 2. Then remainder is 3. Answer is 3. Remainder is 0. Again, when you divide it by 2, you get the answer as 1. And balance remainder is 1. So when I look into this, how do I make my reminders only? I have to take the reminders into account. So I'll put 197 down. I'm not giving the design to that. Wait. Yeah. Let me remove these things. So now, if I have to write the values here, just carefully see. I write this as 197 to base 10. I'm writing 197 to base 10 is equal to 1. Starting this one. From the bottom, you have to go 1, then 0, then 0. How many zeros are there? 1, 2, 3, 4, 5. Right? I hope I've written 1 0 wrong. Yeah, here I have to put 1, no? Yeah, I have to put 1. So 3 zeros, then 1, 0, 1 to base 2. This is to base 2. This is how we get the answer. Is it clear for all? Perfect. Understood, Imran? So now I know how to convert the decimal number into the binary system, but now we have to convert the binary number into the decimal system. I just showed you tens place, hundreds place, thousands place. Like that we have in twos in this place also. 2 to the power of 0, 2 to the power of 1, 2 to the power of 2. So I will increase the size of the numbers of the table. I hope all of you can see now. Right? So 2 to the power of 0 is 1. 2 to the power of 1 is 2. 2 to the power of 2. That means this is first place, units place, 2's place, 4's place, 8th place, 16th place, 32th place, 64th place, 128 place, 256 place, 512 place. Like that, it will be the digits, digit places, place values for in the binary system. So we have 1, 2, 4, 8, 16, 32, multiply by 2 all the time. So that's how we get our number. Now, suppose I got a number. Let me remove this number, what we got in the previous case. I'll get that number and then I will try to convert this number back into your decimal value. So if I put that, my first number will go here, 1, and this number will be 0. This number will be 1. This number, 3 zeros I have to put. Okay, sorry. This is 0, 0, 0. 3 zeros I kept. Then I have 1. Then I have 1. So I got 1, 1, 1, 2, 3 zeros, 1, 0, 1. Now, how do I make it into the normal digital number, decimal numbers? So just multiply whatever answer you have. 1 into 1 is 1. Then 2 into 0 is 0. Then 4 into 1 is 4. Then 8 into 0 is 0. 16 into 0 is 0. 32 into 0 is 0. 64 means 64. This is 128. If you just add, this is to base 2, we have the number. This is to base 2. Now, you add those numbers, what we got the answer is equal to. Can you add the numbers? 128 plus 64 plus 4 plus 1. How much are you getting? 128 plus 64. So I'm getting it as 197 is equal to 197. 128. Got it? Is it correct? 12, 8, 9. 190, 192, 193 and 4, 197. This is how we got the answer. So is this clear now, all of you? In the decimal format, this is in the decimal format, we get the answer. Sorry, this is down. Is it clear now, all of you? Perfect. Nani, is it okay? Abdul, are you able to understand? Put your thumbs up. Did not understand? Why? Understood? How many of you have understood? Put your thumbs up. Good, good. All of you? Harish, Harshita, are you all following? Perfect, dear. Nice. So I'll continue. Now, in the same manner, we have, so we could convert any number you take it, convert into the decimal format or decimal format to the binary format. Both you have to do it in your number systems. Same manner, let me go back to our this thing class part. Once again, I'll open the 7th unit. So like this, we have the decimal format. From the decimal format to binary format to decimal format, we should convert it. Then we have additions and subtractions also in that. Let me speak division by binary method, this method. Yeah, so this is all the procedure what I wrote in the system, but not necessary now. You all know how to work out. Now, suppose if my numbers are having decimals. Decimals means there is a point and after point I have to write my values. Then it is difficult, right? It's not very easy to work out on that. So let me show you how to work out on the decimal part of it. So when we have the decimals, for example, I have a decimal number and let me tell about a decimal number 0.0 467 or 468, whatever be the number. So I have the number 468. How do I put it into the decimal format? Or how do I convert into the decimal format? This one. So first of all, you have to work out in the same procedure in the decimal format only. And then where is it called? So first I will take it easy to make it easy for you. I'll take the decimal number in the binary format so that it will be easy to understand. Then I'll come back there and then give you the values. So here we know that 2 to the power of 9, 2 to the power of 8, 2 to the power of 7, 2 to the power of 6, up to 2 to the power of n and 2 to the power of 0. There are numbers less than 0, less than 1, right? So those values we need to write. Let me draw the table for that. Less numbers. Okay. First, let me put the table and then put the values. This is in the binary format. So I'm putting the table for you. Binary format. I'll put as, make it 0 here. 2 to the power of 0. 2 to the power of 0. I think I wrote once 2 to the power of 0. Yeah, this one. So now we have the numbers 2 to the power of 0, etc. These are the values what we are going to get. Yes. Can you see now? 2 to the power of 0 is 1. But the number 2 to the power of minus 1 is nothing but 1 by 2. Minus 1. Anything raised to the power of minus values, they go to the denominator. So 2 to the power of minus 1 will go to the denominator. It will become 1 by 2. 1 by 2 value is nothing but 1 by 2 value is 0.5. Then 1 by 2 to the power of minus 2 is 1 by 4. That is nothing but 0.25. Then 2 to the power of minus 3 is 1 by 8. That is nothing but 0.125. Just divide each number by 8, by 16, 1 by 16, 1 by 8, 1 by 32, 1 by 264. Like that, you should keep dividing the numbers. Then you will get the decimal values. Now, if I have a number like this, 0, 1, 0, 0, 1, 1, 0. In this number, what I do is, I'll just substitute whatever be the values, multiply by 32 numbers, and then get the values. Okay. So, who is this who is doing all this nonsense? So, we have the binary operation 0.10112, which can be written as 0.0625. Here, our number is there. 0.0625. I have taken 1101. This number I have taken. So 0.0625 is the value of that place. Then 1 into 0.125 is another place. Then 0 into 0.25 and 1 into 0.5. I multiply all those values. Everything will come as 0.6875. That is the binary value we got it. Is that clear? A decimal value to binary value to decimal value. In case if you have a number of this kind, let me take, the screen is troubling so much. Whoever is doing this work, please refrain yourself from all this kind of nonsense. Others cannot understand, others cannot see. And behave yourselves when you are working out, listening to me. Now, suppose I have 1101.101. This is the number I got it. This number, by looking at that, we understand that it is in the binary format. I have to convert that into the decimal format. Let's see how to convert into the decimal format. I'll take the table for myself. 1 second. I'll take the table so that this table will help me to put the values in the proper format. Now, how many places are there? Let's first check. 1, 2, 3, 4, and 5, 6, 7, 8 places I need. So I'll remove all these values first of all. Let me remove. Now 8 places are there. Let me put 2 to the power of 0 here in the center. 2 to the power of 0. This side it will be 2 to the power of minus 1. Correct? 2 to the power of minus 1. Then we have 2 to the power of minus 2. Then we have 2 to the power of minus 3. I think we need only 4 digits. So let me work on that. 2 to the power of minus 4. Then coming to this side, 2 to the power of 1. Then 2 to the power of 2. 2 to the power of 3. 2 to the power of 4. These are the numbers. So let me put the values. 1, 1, 0, 1. No, I should not have this one. 1, 1, 0, 1. Your number should end at 2 to the power of 0. Units place should be there for us. So here you have units place, 2's place, 4's place, 8's place. So I have taken units place, 10's place, sorry, units place, 2's place, 4th place, 8th place. Now coming to the decimal value part. 1, 0, 1, 1. These are the values we got. But I should know the values so that I can multiply them, right? So what I do is I'll put them into the next value. And here I'll write this number is 8 for me. This number is 4 for me. This number is 2 for me. This number is 1 for me. This is 0.5. You all know just now we have done that values. This is 0.25. This is 2 to the power of 8 is 0.125. This is 2 to the power of 16 is 0.0625. 0.0625. These are the values. Now what I have to do is I'll convert them into the normal format. So how do I convert into the normal format, decimal format? Let me put 1, 1. 1101.1011 base 2 can be converted into is equal to, let's check. So 1 into 8. 1 into 8 plus 1 into 4 plus 0 into 2 plus 1 into 1. Up to decimal value I have done. Now plus 1 into 0.5 plus 1 into 0.25 plus 1, no, I wrote 0, 1. 1 into this is 0, sorry. This is 0. 1, 0, 1, 1, no. 0, 1 into 0.125 plus 1 into 0.0625. This is the answer. So that is equal to, you have 8 plus 4 plus 1 plus 1 into 0.5 is 0.5 only, plus anyway next part is 0, plus 0.125 plus 0.0625. If you add all those things, you will get the final answer. 8 plus 4 plus 1 is 13. 8 plus 4 plus 1 is 13. So is equal to 13 point. Now, there are 4 decimal places. In the 4th decimal place, we have 5. So let me put 5. Then coming to the previous one, we have 2, third place. That means this is 2 plus 5, 7. So we have got 7 in the previous place. Then coming to this 6 in the second place, 6 plus 2, 8. No. Yeah, 6 plus 2, 7. No, 8. This is 8. Then comes the previous place. First number is 0. This is 1. This is 5. That is 6. So this is the answer you got. 13.6875 to base 10. Clear, all of you? Is it clear? Doubt? Any doubt? If you have the decimals, any doubt you have? Clear? Shall I repeat one more? I'll send for each one. Once again, you want? Okay. Just a small number I'll take and then show you. Once you understand this, then octal and the other things will become easy. That's why I'm taking this a little elaborate manner. Okay, I'll work out one more simple problem with the decimal part of it. I don't know how much, whether it is really useful or not. So I'll take it as 26. Okay, I'll take a little bigger number. 18, yeah. So 26 point, okay. 1101, some number. This is in the base 2 format. So same concept type I'm taking, same decimal values I'm taking, so that it will be easy for us to work out. Only for the calculation purpose. In the worksheet, I will give you the problem so that you can work out. So these numbers I'll remove. Now, if you understand, we have 8 places. From units place, carefully see this number. You have this place is units place. The first place is the units place. Any number is in the units place, tens place, 100 place, 1000 place. Same manner in the binary system, unit place, twos place, 4 place, 8 place. 2 unit place, 2 twos place, 4s place, 8 place, 16 place. So this is units place. Then comes the next one is 2s place, 4s place, 8 place. So I started my number with 8. So I'll put 1, then 1, then 1, then 0. Now decimal values will start 1, 1, 0, 1. Now, if you multiply here itself, I have not put that extra calculation part. I'll multiply the down number with the previous number. So top and bottom, you start multiplying, you get 0.0625. Directly you get it here. Anyway, this value is 0 for me. Then coming to this 0.25 will become. Then coming to this 1 into 0.5 is 0.5 only. Then you have 1 into 0 is 0. Then coming to the next one, it is 2. Then next one, it is 4. Then next one, it is 8. Now just add all these numbers right from here only you can add. 8 plus 4 is 12. 12 plus 2 is 13. 14. 14 point. Then you add the digits. So I'll write it as 14 point. Then first values I'll add. So 5 plus 2. 5 plus 2 is 7. Wait, just a second. I forgot to on. University paper. I'm unable to unmute myself. Hello, can you see? Yeah. Okay, so can you hear me? Can you
Yes,
hear
ma'am.
me? Yeah.
Yes, ma'am.
Yeah.
Yes, ma'am.
You all please wait. I will complete this concept and then later on you can leave. 2 minutes, another 10-15 minutes more. Okay. Okay. So let me continue the concept. So here we got this part as 7. Then 5 plus 6 is 11. So that is 1. And then 1 is getting carried out. So actually we should add it as 0.5, 0.25, 0.625. So we have 2, 11, 1, 6 plus 1, 8. Yeah. So actually you are getting the answer as 8125. That's how, just adding. The last column is just adding. This is nothing but to base 10. You are going to get as the base 10 value. Oh, base 10. So our actual number in the binary system is 1110.1101 to base 2. This value I have converted into decimal value. Okay. So now we have the same manner, the values not only in the decimal format, we have even in the octal format, in the octal way. Octal means, this is all again examples are there in the problem. In the workbook, it is given to you in the this thing. Then we have how to divide and all the same concept what I have explained you already. And there are certain names for this. The twos place, the twos place, tens place, and all. We have some names for those values. What are the names? Let us see them. So these values are, you are able to see this screen, right? So 1, suppose units place, we call it as a bit. Units place, we call it as a bit. 4 place, we call it as a nibble. N-I-B-B-L-E, nibble. 8 place, we call it as a byte. We call nowadays bytes. What are bytes? 8. 8th place is called a byte. 16 is called a word. Then 32 is called double word. 64 is called a quad word. So these are the values or the names, common names that are given to the binary digits. Units place, tens place, hundreds place, thousands place, how we call for decimal values. We have in the same manner the values, the units place, twos place, fours place, 8 place, all these things we call it as bit, nibble, byte, word, double word, quad, etc. So these are the names for that. Then all these are the binary. Then bigger numbers are there. Suppose I have 2 to the power of 10 or 2 to the power of bigger values are there. In that case, we call them as the kilobyte, megabyte and all, we understand. But what is a kilobyte or what is a megabyte? So if you see here, kilobyte, 2 to the power of 10 is 1 kilobyte. That means 1024. You multiply 2 into 2 into 2 into, like that 10 times if you multiply, you are getting a kilobyte to 1024. Then 2 to the power of 20 is called a megabyte. That means you can read it as 10,48,576 is 1 megabyte. Then gigabyte, this big number, 2 to the power of 30. Then comes a very big number, 2 to the power of 40, etc. So terabyte, all the big numbers will be coming to you. We have, next comes the octal system. Like in binary system, 2 means up to 2 will be there, but not 2. 10 means up to 10 will be there, but not 10. Getting me? You have the numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, but not 10 will not be there. 10 is separate numeral, separate symbol will not be there. It is 1, 0. Same manner, suppose in the binary system, if I have to write 2, I will write it as 1, 1, 0. In the binary system, if I have to write 2, I have to write it as 1, 0. Suppose I have to write it as 2. So how do I write this 2 in the binary system? When you divide it by 2, 2 divided by 2 when you write it. So you are getting the answer as answer is 1, and beside that you will get it as 0. If place is there, I'll write here. 1 second. Somewhere place was there so that I can write. Yeah, I'll put it here. Don't worry. So now suppose I'm left with, forget about the above one. 2 is there, 2 with 2 I'm dividing it. So I'm getting 1. The answer remainder will become 0. So here what will happen, this 2, when you divide it by 2, you are getting the answer 1 and the remainder is 0. So 2 in the binary system is written as 1, 0. That is nothing but like 10, right? So same manner in the octal system, we are going to work with the octal system now. In the octal system, we have 8 digits, 0, 1, 2, 3, 4, 5, 6, 7. 8 will not be there. But number of digits are 8. See here, 1, 0 is the first digit, second digit, third digit, fourth digit, fifth digit, sixth digit, seventh digit, eighth digit. So there are 8 digits, but 8 will not be there. 8 number symbol will not be there. If I have to write 8 here, then I'll write it as 1, 0. I'll write it as 1, 0. And 9, if I have to write, I'll write it as 11. 12, 10 I have to write, then I'll write it as 12, like this. Getting me, all of you? Suppose 13, then 14, then 15, then 16, then 17. Next number will be 20. Same manner, if I have to write 1, 2, 3, 4, 5, 6, 7, 8, sorry, decimals and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10, 11, 12, 13. These are our normal numbers. Same thing if I have to write in the binary system, 1 will be there, 2 will be 1, 0, 3 will be 1, 1, 4 will be 1, 1, 0, something like that. It goes on that numbers. Whereas in the octal system, after 8, 8 is written as 10, 1, 0. And 9 is written as 1, 1. How 9 is written as 1, 1? Suppose if I have to put, I'll take the table format so that it will be easy for you to understand. Just a few more lines. Okay. I'll show you in this how 8 will come. Let's think I have some 15 number. I have to divide it by 8. 15, how many times it gets divided? 1 time it gets divided. What is the remainder you got? 15. Remainder is 7. So our number is nothing but 1, 7 for 15. So here, this is your 9. This is your 10. This is your 9, 10, 8, 9, 10, 11, 12, 13, 14, 15 is nothing but 17. Got it, all of you? I'll make it, suppose, for example, I need 57. Let us take 57. 57 means, how do you write this 57? 8, 7s are 56. I'm left over with 1 number. Next comes, there is nowhere it gets. So your 57 can be written as 7, 1 in octal system. Suppose, let us think I have 148. Okay, I'll put it as 169. Some number I took. So 169 when I took, how do I write this in the octal system? 169. How do you divide it by 8? How many times it goes? See, 8 2s are 16. 1 remainder, 0. And 9 will be there. So 1 time it will go. So the answer is left over is 1 left. Then 21, can you divide? Yes. How many times can you divide 8? That is 8 2s are 16. 8 2s are 16. So 5 more is left. So answer is 5. So the final answer 169 can be written as 251 in octal system. Exactly the same manner what we have in the binary system, we will be converting into octal. There we were dividing it by 2. Here we will be dividing it by 8. Same manner we have octal system, hexadecimal system. Hexadecimal system is more huge numbers. It is 16-digit numbers, up to 16 digits. So hexadecimal is more complicated one. Let me show you the hexadecimal. So these are all about the octal system. You have units place, 8th place, 64 place, 512 place, because 8 cube is 512. 8 to the power of 4 is 4k, that means 4000. 8 to the power of 5 is 32k. I have written all the values for you to explain, so I'll give you the values. 8 to the power of 6, 8 to the power of 7, millions only, 16 million, 2 million, like that. So octal is not initially they started using it, but from octal the numbers went to bit binary, then combining, not necessary all this, binary digit value. Okay, I'll go to octal digit value table. This is comfortable for you to know. So now I have 0, 1, 2, 3, 4, 5, 6, 7 and 0, 1, 2, 3, 4, 5, 6, 7. Suppose if I have my 8 number. So if I have 8 number, how do I get 8? 1 and 0 if I put, that will become my 8. Then 6 and 13. So if you just do it, then you will get the value whatever it is in the number system. So using this part, table format, we can handle the octal systems very easily. In octal system, of course, we have how to add the octal systems. Addition, subtraction, multiplication, division, all these are there in the octal system, binary system, and hexadecimal systems. So in the octal system, if I have to add this, if you see carefully, 4, 5, 6 is to base 8, 1, 2, 3 is also to base 8. So if I have to add in those bases only, right? So 4 and 6, it is 9. But in the octal system, if it is 9, how do I write 9? As 1, 1. So 1, you will write 11, you don't write, no? 1 down and then 1 as the carry on. So 1 here and 1 carry on. Then 8 plus 5, 5 plus 1 is 6, 6 plus 2 is 8. 8 means 10 in the octal system. So 10, that is 0 here and 1 here. Then you are adding 4, 1 plus 4 plus 1, that is 6. So 601 to base 8. In the normal numbers, if you have to add, convert them into the normal numbers. 302 and 83, you get it as 385 in base 10 system. Addition, subtractions are very easy, but multiplications also, but little more, we should do a little hard work in that. So in the subtraction part also, octal subtraction, 6 minus 3 is simple for us, that is 3 only. Then if I have to carry 5 and 7, you can see this. I cannot subtract 5. I cannot subtract 7 from 5. So if I cannot subtract, how do I do it? How do I do? I will carry. In the normal subtraction, what do? We get one number from the next place, 10 from the next place. Instead of 10, here you have to get the 8. So you get 8, then 8 plus 5 is 13. 13 minus 7 is 6. Okay, now this 4 became 3. So 3 minus 1 is 2. That's how we do this. Then comes to the hexadecimal numbers. Hexadecimal numbers are 16-digit numbers. 10-digit numbers, 10-digit numbers we did, 2-digit numbers we did, 8-digit numbers we did. Then we are doing 16-digit numbers. There is a duodecimal system also. In the duodecimal system, it is 12 decimals will be there, 12 values will be there. Whereas in the hexadecimal, it is 16 digits. How do we write 16 digits, ma'am? We have only 8, 9 numerals or 10 numerals. How do we write 16 digits? So 16 digits cannot be written. We can't write. Only up to 9, we have the symbols for writing the numbers. So what do we do is, if you see carefully, 1 to 9 will be there. 0, 1, 2, 3, 4, 5, 6, up to 9 can be written. After 9, 10, 11, 12, up to 16, up to 15, we can write it with A as 10, B as 11, C as 12, D as 13, E as 14, and F is 15. That is how we write. I'll show you how that looks. Where is it? In this one. 4 digits. One more table is there. Hexadecimal. Yeah, here. So if you see this one, please can go. So in this, if you see 0, 1, 2, 3, 4 up to 9, then this is the 10th place. 10 is A, 11 is B, 12 is C, 13 is D, then 14, then 15. Again, 16 means 16 will be 10. It will be written like a 10 value. Is it clear for all? Right. So this is the hexadecimal system we have. So in the hexadecimal system also we have additions and subtractions. Those additions and subtractions, of course, not very much you should focus on. Suppose if you have A and B are there. So you should remember A is 10, B is 11. Simple. 10, 11, 12 you write, and A is 10, B is 12. So add them and then write the answers. That will make it easy for you to complete it. So this is how for today's class for hexadecimal systems and all. Yeah, done. That is the last one. Anyone having doubts in the class today's? Understood? Clear for all?
Yes, ma'am.
Yeah. Today itself, I will send in the group, in that WhatsApp chat group, I'll send you the problems of binary, the octal, and hexadecimal problems. So I will solve one problem. Looking at the problem, you can do 3 to 5 problems based on that. Will you complete the assignment till next Saturday?
Yes, madam.
Yes, ma'am.
Because if you do, then I will have more interest to give you good work and then make you learn better. Okay. So today itself, in the night, I will send you each one addition part I'll give you. I'll show you how to do it. One example problem. It's not easy for you to quickly grasp as I'm explaining. Once you see, you will understand it easily. I'll write very elaborately. If you don't understand, you can pin me and ask me the doubt. Is it okay?
Excuse me, can you forward total units in PPT?
All the units today night you are getting it. PPTs
Okay,
you will get it. Notes part in a day or two. I have to write a little more. I'll send it.
Thank you.
Okay.
Okay, ma'am. Thank you so much.
Okay, then we'll end the session today.
Ma'am, previous year's question papers, ma'am.
Question papers, I'll try to get them. Okay.
Thank you, ma'am.
Yeah, okay.
Thank you.
Take care, all of you. Have a nice weekend and happy week.
Thank you, ma'am.